Let's say welcome and thank you for joining us for another episode of the Jane Irrigation training series. And today I'm really excited to be talking about whole orchard recycling. And the reason I'm excited about that is because, I talk to people all the time about sustainability and conservation. It's a daily conversation I have almost all day long. And people a lot of times want to point the finger at agriculture and say, you need to do a better job. And in actuality, I love to tell them that there's a lot of growers today that are doing a really good job, and there's a lot of education around newer and better ways to farm and grow that are more sustainable, that are very conservation minded. We've got a lot of stewards of the environment working in agriculture, and their practices are becoming more and more popular today. And this is certainly one that is cutting edge. And today, taking us through this segment is Cory Broad. And Cory, for those of you who have seen Cory, does a great job on these. Cory's our key grower development manager at Jane Irrigation. And more importantly for this discussion, Cory is a certified crop advisor, he's a certified irrigation designer, and he's a certified ag irrigation specialist. He's a lifelong resident of the Central Valley. He is very passionate about agriculture. If I was going to start growing in the Central Valley next week, Cory would be my first call. And so with that, I want to say welcome, Cory. Thanks for joining us today. And man, what's caught on? What is this whole orchard recycling all about?
Well, thank you for the kind words and introduction there. And this is, I think, my sixth opportunity to speak to everybody. So for those of you who've watched multiples, I appreciate you as a return customer there. And but really looking at whole orchard recycling, it's such a unique concept, yet it's very it's complex but easy at the same time. It follows a lot of basic principles in different types of growing and soil management. And I think it's something that we're going to continue to see more of, that you see in a number of different industries, and support groups have done a fantastic job doing research on this. And again, with the continued increase in almond acreage, as well as these older orchards that are coming out and these generational changes, I think it's a great opportunity for growers to have another access to another practice that can really enhance what they're already doing from production and environmental stewardship.
Yeah, great, complex but easy. I like that. That's somewhat designed for me, I think. And I just want to remind everybody, as we're going through Cory's presentation, I've got both the Q&A and the chat open. So if you have some questions that you'd like me to pass on to Cory or ask when it's appropriate, put them in the Q&A or the chat, and we'll do that. So, all right, let's go, Cory.
Perfect. Well, no need to spend much time here, as you did a great introduction, but this is just some of my background for those of you who aren't familiar with me. I think the only thing you left out was my formal education from Fresno State. So I always like to plug Fresno State, a great agricultural school here in the Valley, and still get to work closely with them on research projects and things. So as always, go Dogs.
Cory, the other one that I left out that I think is quite impressive is the Agriculturist of the Year in Madera County. I don't know anyone else who's gotten that type of an award. That's a big one. And that's really from the growers, the people in the area that are working and doing this every day. So I actually think we both left that one out, and I didn't want it to be left out.
No, I appreciate that. That was certainly an honor and something I definitely try and hold up to every day. So moving through the topics, I think I always like to try and put a roadmap for where we're going to go today. And these are the 5 questions that hopefully I can answer for you. And maybe you had some of these questions going into the webinar. But what is whole orchard recycling? How does soil organic matter impact my field? What's the net benefit of whole orchard recycling? And then how is that going to impact the fertilization of my field? And then also, what are the strategies for that young orchard irrigation in the new planting that's going to follow this whole orchard recycling? So whole orchard recycling is a concept in which orchards that are being removed are turned into productive matter that can be used for future growing productivity. So traditionally here in California, what we would do is we would identify an orchard that was generational and needed to be removed due to declining production or a number of other factors. what we would do is we'd knock the trees down, and then we'd stack them in piles, let them dry. And then eventually, once we were allowed to, we could burn those trees. And allowed to, I mean, the Valley Air Board and some of the other districts and state entities allowed us to do that based on particulate matter. And then obviously with increased regulation on air quality and pollution, it's become more difficult. There's fewer and farther burn days that are allowed here in the Central Valley. So right after the storm that you and I were talking about during the introduction, allowed people to burn. Now that we're looking at a clear forecast, there are fewer opportunities to burn just because the particulate matter index increases. So it's become a less reliable source of removing your orchard. And the challenge becomes you have to get all of the old orchard out before you can go and do ground prep and put in new irrigation and get your berms ready and all the things that you need to do to prepare for this next 25-year investment. So it really can mess with your timeline and mess up the contractors and people you're working with on those schedules. So another unique thing is the whole orchard recycling really lines up with the Almond Board of California's 2025 sustainability goals. And so I think it's just another unique opportunity where different parts of the industry are all working together.
Yeah, so Cory, this is, and I could tell in particular before we signed on, how passionate you are about this subject. And I was just wondering, why do you feel this isn't so important to discuss?
And you touched on some of it during the introduction as well. Farmers are doing a fantastic job in the face of increasing regulation as far as environmental stewardship and hopefully, being able to produce sustainably so they can hand down to the next generation. And there's a lot of young agriculturalists like myself that are out there that believe in those technologies, believe in those practices. Like you said, I live here, I grew up here, and I work with people that are literally right down the street from my home. And we all have a vested interest in, clean air, clean water, soil, and things like that. So I just feel like it really lines up well. And it's also a unique alignment with our company's philosophy. Jane's mission statement is to leave this world better than you found it. And again, this is just another form of, I believe, doing that.
Yeah, excellent. And then that's really great to hear. And then the other thing, I've got a question from the audience here on is, when you say they used to knock the trees over basically and burn them, that's kind of the old way. You're going to tell us about the new way. Is that correct?
Yeah, and I want to say old way. I would just say it's the more standard practice in the industry. And so there are more people looking at this whole orchard recycling as an opportunity. Again, it doesn't fit everybody's operation, and we'll talk about some of the nuances of that later on in the presentation. But it's something that, again, the California Almond Board and the UC and a number of different groups and cooperatives have sat down and said, how can we do this better? Again, we as stakeholders in agriculture are listening to people who maybe aren't directly involved and saying, hey, is there something you can do? And we're saying, you know what, let us look at that, and we will. And I think this is just one of those things that's coming out of that, and we'll continue to do so going forward.
Very exciting. Thank you, Cory.
Of course. So as I mentioned in the last slide, we talked about those 2025 goals. And again, I wanted to give props to the California Almond Board. They do a fantastic job. I know a number of people that work there in different capacities. And these are their 4 kind of pillars for their 2025 goals. And so I talked about that zero waste in orchards. I think the whole orchard recycling program really fits in that. But it also impacts irrigation, as we'll talk about today. And so again, they want to continue to reduce the amount of water it takes to grow almonds. And then there's a few others talking about air quality during harvest, as well as environmental impacts and pest management. So I just felt like those are very good goals. And again, another example of what the industry is doing. And I wanted to share that real quick. So looking at whole orchard recycling in almond production specifically, what we'll do is the orchard materials will be processed into wood chips and then spread and incorporated into the field soil area. That's obviously a direct benefit immediately from reduced air pollution because we've eliminated that burning that we talked about earlier. But also it gives us an opportunity to talk about closing the loop, which is something that's discussed in regards to sustainability across a number of industries. And I think that agriculture can join that conversation as well. We produce these plants. Now we're using as many of the pieces of that plant and the products as possible. And then when we're done with that plant, that biomass is just another example of something that we're going to use. And that's, again, in my mind, closing the loop in this entire process. Now, of course, there's going to be an expense associated with doing this, as you're going to have grinding and shredding and spreading equipment. And usually that needs to be operated by a professional. And so please don't just go rent it and go do it yourself. I think you should work with a consultant and probably work with a company. There's a number of companies here in the Valley that are starting to specialize in this task. And again, there is a cost, but it's also an investment. This is a 25-year orchard that you're putting in, and maybe a generational investment as well. So consider it an investment through healthier air, soil, and then also hopefully reduced water quality, impact on water quality as well. So looking at soil organic matter, obviously incorporating all this material in this biomass into our fields can increase that soil organic matter that we have. And usually Western soils, specifically in California, tend to have lower amounts of organic matter. That's because we have warmer temperatures. As you know, it can get very warm here in the Valley, especially. And then you couple that with irrigation water being applied, it's kind of the perfect storm for the breakdown of organic matter. And so why soil organic matter is important is it helps create stable aggregates, which basically improves your soil structure. It's a better foundation, if you will. And one of the unique characteristics of soil organic matter is aggregation using that is much stronger than even some of the chemical bonds through amendments that we put in our fields. And so I'm not saying that amendments are a bad thing or an unworthwhile investment. I'm saying that soil organic matter is something that can enhance that investment and practice that you're already having on your farm, your operation. So again, it's an enhancement. It pairs well with what you're doing already.
Yeah, so Cory, I hear all the time, right? I need to have a lot of organic matter in my soil, but I never really know how much I actually have. What's a way that I can figure this out or find this out?
Yeah, definitely. And we talk about organic matter even in the landscape industry and gardens and things like that as well. And in agriculture, I know for us, it's I'd say easy to get in the sense that there's a lot of consulting companies and laboratories out there that can come and take soil samples for you if that's something you don't even want to do yourself. And they can analyze that. They can give you a lot of properties of your soil, but one of the numbers that they can provide for you is your organic matter content.
Good to know. Thanks, Cory.
Absolutely. So again, increasing your soil organic matter gives you an opportunity to increase that water use efficiency in your orchard. And if you look on the left-hand side, there's some infographics there from UC Davis. They've done some research on this, as I've alluded to before. And these are some of the numbers that they've talked about with, increased water holding capacity, infiltration rates. I mean, there's some pretty staggering numbers and increases there on, again, some of the research plots that they've used. And so what's, again, related back to soil organic matter is going to increase that water holding capacity of your soil. It's going to increase that available water holding capacity of your soil, which means that's plant available water. Your infiltration can be increased and your nutrient retention can be increased as well. And those are all really powerful things, as we'll jump into a little bit later. But again, that water use efficiency, the profile is going to hold more water and it's going to make it more plant available. Those are two distinct things that need to be mentioned. And then again, that increase in infiltration rate is going to reduce evaporation because you're getting water into the ground. And that's really important, especially in young orchards with limited ground cover. So an example of this, kind of overly simplified, but I think it drives home a good point. If we take, just say, a 36-inch root zone in a mature almond orchard, and we identify that as our root area, and we use the chart on the left-hand side as a common chart you can find for water holding capacity based on soil text class. And there's a few different revisions of this, but nonetheless, if we say we have a sandy loam profile, that means that it'll hold 1.25 to 1.4 inches of water per foot of soil. So if you take that, you multiply it by your 3 feet, you essentially would have 3.75 inches of plant available water if you said, I'm going to use the low end of that spectrum. Now we're going to assume that we're going to use about 0.29 inches per day based on a specific time period of crop development and weather. And our irrigation system puts out 0.035 inches per hour. Those are all very normal numbers for what we would operate with here in the Central Valley. So if you divide the daily water use by what your max capacity is, if your soil is full, you essentially have 12 days of available water. Now, the last thing you want to do is take these trees on what I call a road trip, fill up the tank, run it down to empty, hope you find a gas station, and it's 109 degrees, and you don't want to have that soil water depleted. So say you identify a depletion of 50% as your threshold. That means you let the gas tank get full, and then you get to halfway, and then you're going to put gas back in again as you go. That's normally what we would do during an irrigation season. So again, that available water is now decreased by half, right? So 6 days of irrigation, just under 1.9 inches of available water. So remember that text class, I told you it was 1.25 inches to 1.4 inches of available water. So let's just take that same number. Let's increase that water holding capacity by just 12%, going to the high end. The infographic from one of my previous slides said they found research showing 32% increase in soil water holding capacity. I'm only using 12% in this example, being very conservative. So now you have 4.2 inches of available water in your root zone. And that's giving you more storage area in that area itself. So now your irrigation set lengths can be increased without the impact of deep percolation, because you're not pushing water through the root zone because it can hold more. Your tank has become bigger. So with that, you can increase your irrigation set lengths. When you can increase your irrigation set lengths, you don't have to irrigate as frequently. Now you can reduce the labor being spent on your operation in order to achieve this. And obviously we know labor is a huge concern for growers of any size and any commodity across the United States and really the globe going forward. So this is just a very simple, unique way of, here's one small direct benefit you can achieve, I think, on a very conservative basis.
Yeah, what an interesting concept, Cory. We really don't hear very much about this, but actually making the tank bigger from the standpoint of having it hold more water, right? Most people are worried about more water pushing through the root zone, but this is a great way to keep it in the root zone because it can hold more. Yeah,
it's certainly an opportunity to do so. And I think that traditionally, a lot of the times we said, well, if I didn't farm or buy a class 1 soil, I have what I have, right? And there's some practices I can do, and there's amendments I can apply. And drip has allowed me to circumvent a lot of these challenges. But now this is just another way to think about how to change that soil profile and, again, make it better for orchard productivity going forward. And I think that's perfect for kind of this next slide. So we all know about Sigma. We've, I believe, had a few webinars on it. There's some more talks that'll be happening at the Fresno State Ag Tech Day on February 12th, where we'll be discussing Sigma as well. But it's beginning to become more and more active. These plans are being implemented in certain areas, especially as far as the crackdown. So water availability in many parts of California is going to decrease, let alone, if anything, just become unstable annually, year to year. And so it's something that we need to prepare for. The UC has their research that's shown that almonds with full orchard recycling implemented in their new orchard have a better yield response when deficit irrigation is applied, which I think is a really great opportunity. And so I look at this as a way to help prepare your orchard for this uncertainty / reduction in water that we are going to face no matter what in agriculture.
Yes, this is really great information, Cory, very powerful. But one of the challenges I have is I don't really know if the water that I'm putting down is actually in my root zone past it or too high, right? And without getting out a backhoe, how can I possibly figure this out?
Yeah, it can be a challenge. I think that's actually a perfect kind of segue in where I wanted to go with this, talking a little bit about technology. Of course, digging a backhoe pit's always great, but it's certainly time consuming and something I don't think we want to do while the roots are flushing and things like that. So if I can, I'll just jump into this next slide. It's a little bit busy. I apologize for that, but I think it drives home a good point here. So this is 2 fields, one to the north, one to the south. They're in orchard production, and there's 2 soil moisture probes, one in each field. And so the top layer of charts, you can see there's 12, 24, 36, and 48, and then it repeats again. So again, 2 different data from 2 different probes at the same time. And you can see the red circles that I've drawn here. Those red circles show 2 different readings at the 36-inch mark. These are farmed the same way, with the trees planted at the same time, irrigated by the same style of system, the same way, and yet there are different responses in water moving through the soil profile. So then you look at the next set of circles that I drew more vertically with the purple color outline. And you can see that this next irrigation event that happened, water got to the 36-inch mark on both of these probes. But also look at the difference on the curves and the amount of water that was retained at those levels. So the best way to get insight into how water is moving through your ground is to put some type of sensor in there that can do that. And obviously with our JaneLogic platform, it offers a number of different, what we call widgets or tools, if you will, that allow you different insights into your operation. But this is one that allows you to track the changes daily, but also think about if you had a probe in your field for 15 years and you were implementing different practices or managing this organic matter, maybe you'd have an opportunity to get some real insight that fits your farm. And I think that's the important thing is research is awesome and they have great data, but also get the data for your farm because that's what's going to really make the impact of your bottom line.
Yeah, so if we could just see that slide one more time, Cory, we got a couple questions about
Yep.
it. So basically, these are two sensors. They're both 48 inches long, right?
Mm-hmm.
And they're taking a measurement every 12 inches.
Correct.
So the blue line is 12 inches, the red line 24, the green line 36, and the orange line 48.
Actually, this is, if you can see my cursor here, this red line is the 12-inch mark. This is actually a summation line up here.
Okay.
So there's, 12, 24, 36, 48, and then it repeats.
Okay. And so the blue line is just the total of those sensor numbers or moisture units on
Yeah,
each line.
it's a reading from one of the probes is summation.
Okay. And what we want to see is we want to see these lines move up. That's actually adding moisture to that soil at that zone.
Correct.
Okay.
Because we were targeting it within irrigation. And so, like I said, these were treated with the same irrigation scheme, yet they responded differently. Despite being farmed again and planted and managed the same way, they're responding differently. And so, again, get that data for your farm, get that data for your field, and understand what that is. The research and some of these larger numbers I've been using are great roadmaps, but you got to get the data for your farm because that's how you're going to justify your ROI. And that's how you can make those changes that'll make your operation more efficient, more profitable.
Yeah. Okay, great, Cory. Thank you.
Yep. So we talked about deep percolation and moving past a root zone. And so for the sake of deep percolation and water use efficiency, that's really water that's, quote, lost, if you will, in crop production because it's moved beyond the root zone or the plant available area. Deep percolation can definitely have some positive impacts when you're talking about salinity management and different things. So it's not always a negative, but for the sake of our conversation on water use efficiency, it certainly is. So we talked about losing that water or moving it past the root zone where it's now unavailable. But what about the energy that you spent to maybe pump that water out of the ground or move it out of a reservoir, energize it, and distribute it evenly across your field? Energy is certainly not getting any cheaper in this state. We all know that. And some old figures say $1 per acre per PSI per year. I think it's probably closer to 2 now, and it's certainly not going to go down anytime soon. So you think about the water loss, think about the energy loss. You have labor being spent on irrigation systems. We talked about that earlier. And then also we talked about that nutrient removal from the root zone and nitrates specifically. We know about the environmental impacts. We know about the health impacts of that. So having the opportunity to keep those things where you wanted them and utilized properly is really important. Just a quick plug again, JaneLogic software on the right-hand side, you see the infiltration chart. If you don't want to have to read all those lines that have a lot of data in a very small area, this is another tool that we have that you can just check. So you can see there were 2 irrigation events in the larger circle there on this side where we got down to 48 inches and actually down to 56 and maybe even beyond on this one. Well, if we were still targeting that 36-inch zone, we've missed that window. Now we can make a corrective action on these next 2 irrigation events. And you can see in this circle here, we landed in that 36-inch zone. If we were fertigating, and then obviously we're applying water, all the necessary resources that we're using as inputs are landing where we want them to land. And that's important.
Cory, that's fantastic being able to see that. Are these soil moisture probes? I mean, are they tens of thousands of dollars or?
Not at all. I believe, you look at the way technology has changed. Think about what phones, would have cost to do the computing power that they do nowadays, 20 years ago, 10 years ago, even 5. I think, as technology and processors and things get better, technology costs go down overall. We've all benefited from that. So no, I mean, it's very easy to get a site set up in your field. It depends on, again, some of the functions and maybe other things, if you want a weather station or not, but there's no reason why you can't get a probe and quality data for, $3,000 to $4,000.
Huh.
And I think that's totally manageable.
Yeah, I mean, we're talking like less than 1% of the total value of the product in my field, right?
Yeah, absolutely. So it's certainly there. The technology's there. It's robust. So if you are interested, please reach out to us. And we have thousands of sites with hundreds of customers, which means customers are using more than one site. That means they believe in it. So I think that's a great story as well. But kind of staying with infiltration now and kind of looking at, again, that chart, but maybe in a different way where we were talking about water moving past the root zone. Well, if we use this infiltration chart here, we can see that there were some irrigation events that didn't hit the targeted area in this specific example, which is kind of that green band that you can see down in here. And so again, those weren't really effective or efficient irrigation events. I mean, I don't identify getting down to 4 inches is really beneficial in a permanent crop setting as you're, again, spending that labor, spending that time and energy, putting water and hopefully, not having much evaporation, but it'll be there. And again, we know that lack of infiltration can cause issues in many orchard situations. You have disease, equipment pitfalls, and then obviously, on the topic of water use efficiency, when you have poor infiltration, you have water pooling, you're going to have evaporation, and then you can also have runoff. Runoff's not as big of an issue in the micro irrigation business with orchard production, but consider, runoff being a big issue, maybe on like a field crop or a veggie crop with a large orifice sprinkler. But it's still something that needs to be considered because if you don't get water in the ground, you're not utilizing it properly. And, in young orchards, especially where you have those large areas of no ground cover and you have this wetted soil surface, you're definitely going to have some evaporation there. And then that can be exacerbated when you use a large pattern sprinkler and you cover this area and have a larger area of wetted soil, you can increase that evaporation pretty significantly.
Yes, we have a question here, Cory, and the question is, how much evaporation are we actually talking about?
So quantifiably, it's going to change based on a number of, what's the weather, what's the wind like, how much of that soil surface area is wetted, what's the actual water being put out. But just talking about going from like drip to a large area sprinkler on a young orchard, it can increase on a single day by as much as 15%. So 15% of whatever amount being, quote, wasted is still 15% being wasted. So it's something that needs to be managed.
Yeah, it's 15% times the amount of times that occurs. This could be really, really expensive in a lot of ways.
Absolutely. So something we want to manage. And then kind of, again, one of the other features of all of this is looking at nutrient retention. So we talked about soil organic matter increasing that nutrient retention, and it's going to come in a few different forms. Obviously, we talked about the deep percolation earlier. So we've made our tank bigger. Hopefully, we're not going to be pushing things past the root zone because we can manage those longer sets better. And so with that, you're not going to be pushing things like nitrates through that profile as quickly. And then obviously, as you increase that soil organic matter, it's going to increase cation exchange capacity in your soil. Cations are essentially positively charged particles. So calcium, magnesium, potassium are some of the things that we would use in orchard production that would be positively charged. Soil is generally, it's a negatively charged base. And so positive charges stick well to it. Things like nitrates don't because they're negatively charged. And so increasing that soil organic matter can be beneficial that way. And then another unique opportunity is soil organic matter increases the buffering capacity of your soil. So that means basically your soil is more stable in terms of pH. And so if the chart on the left-hand side, I'm sure many people have seen, that is a nutrient availability chart and basically has a varying scale of different pH levels and then what elements are affected by that. So again, a soil that is more stable in terms of pH is easier to farm because you and your advisor can look at it and you probably have a good idea of what the deficiencies might be based on a pH that isn't wildly changing. And then again, just to break down that cation exchange capacity, I know it's kind of a mouthful there, but I found this illustration a while ago, and I just think it's really unique and simplified. I told you complex but simple. We'll stay with that theme. So you can see clay has a much higher cation exchange capacity. It is much more able to hold on to those positively charged elements. And then you have like a sandy loam profile on the other side that has a much lower cation exchange capacity rating. So again, just a unique kind of visualization and me throwing out a lot of acronyms. And then talking about those elements and positive and negative charges. These are the micro and macro nutrients that we use in crop production. And we talked about nitrates being negatively charged earlier. If you look here at the top right, this is nitrate, which is obviously a plant available form of nitrogen. So NO3 negative. So that negative charge, it's not going to bond to your soil particles. It's going to move with the water through the profile. So we want to make sure that stays in that area. So that's where, again, filling that tank and making that tank bigger comes in. So now I've told you all these great things it's going to do for you. Now I've got to do the sales pitch, and I'm going to tell you how much it's going to cost. So again, please consider it's an investment, which is going to require upfront costs. Those are going to look something like $600 per acre in grinding costs. And then it's going to range on the incorporation costs of $250 to $400 an acre, depending on where you are, who's going to do it for you, a number of different factors there. But let's just take the $1,000 an acre assumption here for grinding and incorporating total. I think your payback opportunities are going to come from that improved water use efficiency. We talk about that nutrient retention. How much is your fertilizer bill every year? If you can use it better by 5%, what does that payback come to you at? And then we talked about decreased labor. That's a cost that's not going down or going away. And I think the best way that I can put all these parameters together, because it's different for every operation, is what does a 20% increase in water use efficiency at 3 3/4 acre feet look like for you? What does 10% look like? If you can write down those numbers and work that in, I think the payback is pretty self-explanatory at that point, especially for a 20-year investment. And then, of course, there are incentives. The Valley Air Board, this is straight from their website. It's actually up there as well. So if you want to jot that down, you can go visit them, give them a call. And basically, there are 2 SKUs or 2 schemes that they'll offer incentives on, potential incentives. So full chipping and soil incorporation, $600 an acre, you can basically get that grinding paid for. And then if you just do chipping and you're not necessarily incorporating into the soil, which you're just spreading, you can still get up to $300 an acre payback. So just some opportunities there to offset those costs as well.
Yeah, they're actually picking up a good, especially the first one, a good percentage of the cost.
Yeah, absolutely. So it's something to look into. I encourage you, if this is something you want to look at, reach out to them, because that's an awesome resource. And then kind of getting into some more of the data part from UC work that they've done recently. This is a study that they did with a control, which is their standard replacement of an orchard, which was that burning method that we talked about earlier, and then obviously a WOR field. And so they did 4 different depths: soil moisture volume and water content, and at 3 different stages. And you can see each time in the WOR field that there was more water present by volume. And so just, again, a unique opportunity for what does my new orchard look like? These are the impacts that it's going to start having. And then obviously there are some things that you do need to really consider though. And looking at that young orchard impact, we've added in, quote, free nutrients. Yeah, I just told you it's going to cost some money, but you put in some elements that'll break down over time and become plant available. But the big thing you have to consider is, if you look at the infographic on the left-hand side, you can see there's a whole lot of carbon that was put back into that ground. That's going to significantly upset your carbon nitrogen ratio, most likely. And that can lead to the mobilization of N. Basically, it's plant unavailable. There's too much carbon compared to the nitrogen, and now the nitrogen that's even in the ground is now unavailable to your plants. So you need to consider the fertilization requirement of your young orchard, and then you're probably going to have to supplement to compensate for that immobilization. That needs to be worked out with a crop advisor. Get some input on that, probably some soil tests, and make sure that that's something you're considering. Now, the other thing is, from an irrigation guy's perspective, if you're using this with fertigation to apply your N to your field, you want to make sure those drippers are lining up with your plants, because if you're putting the nitrogen through, it's getting into the soil, it may still get re-tied up in the soil again as well. So you want to make sure that what you are delivering via fertigation is getting to your plant so it can use it right away. So going into dripper placement, there's a few different options. If you're using a button style dripper, you can see our clip tiff button dripper over here on the left-hand side. Placement at the base or nearby the tree is preferred. The great thing is you can add drippers as the trees grow, the water demand increases, and you can match the application rate of your system. We offer a number of different flow rates, half, 1, 2, and 3 gallon an hour. And then obviously you pair that with our premium emitter line, or excuse me, our premium blank tubing with a 12-year extended warranty, an industry leader for sure. That's going to help you maximize your investment and the life of your products in your orchard. Now, if you say, I want to use inline emitters because I don't want to deal with more labor in the future, that's totally acceptable. One thing to consider is, and you can see here that where the lines connect in the middle of this, in between trees, top of the berm, that's actually just a little bit of tree rope that the guys tied and held the lines together. Helps keep things tight at the top of the berm and right on the center, and then keeping those emitters close together because most likely they're staggered. The lateral water movement from those two emitters hitting each other increases the odds of it actually hitting your tree root ball, depending on the spacing. So just consider that. Even if you line up your emitters early on, we talked about it being 64 degrees here in Fresno. Well, it's 35 at night, and a lot of expansion and contraction is going to happen. And then by July, it'll be 70 at night, and it'll be 100 during the day. And so those emitters are going to move at the base of that plant. And so you want to make sure to keep an eye on that. One thing that we have an advantage on with our Amnon emitter line and even our top drip emitter line is that it's made with 100% virgin resin. That's going to reduce inconsistent expansion contraction in your field, and that's going to help those emitters stay put. Now, I've thrown a lot at you. I can see it, Richard. I've thrown a lot here. I know I have, but here's the great opportunity is we've had some webinars on this recently, but our Jane Water Management Services, it's brand new to our company, but the philosophy really isn't. We've had this practice. We just realized that this is something that growers may need because of all this technical expertise that we have. With our comprehensive water management service, we can take a lot of these factors that we just discussed and basically do the homework for you, and then monitor your irrigation system performance, audit the irrigation system. We put a probe in to manage your field water status, and then we're using our satellite imaging and technology to look at your actual crop water use and uniformity in your field. I call it completing the triangle. And then with that, you get a detailed irrigation report provided to you by an irrigation expert like myself. We're going to walk you through the irrigation season and help you make those management decisions, help you drive that boat.
Yeah, what a great service, Cory. And you were right at the beginning when you said this is complicated but easy. And I think what is the complicated part is there's so many things to think about, right? And you did a really good job of bringing those up. And what I really like about the water management services is that I can work with somebody, right? Anytime I've done any endeavor on my own versus having a coach or a mentor help me through it, the learning is accelerated when I get some help. So if I can get some help on this, man, this is something I want to take advantage of. I'll eventually be able to go out on my own, but I'm going to be there so much faster. I'm going to get so much better yields and cut down on labor as a result of this. And that's why I like it so much.
Yeah, certainly. And that's our goal with this program is to work with growers very closely. And again, coach you along, be there and say, hey, when you need us in the future, we're here. But if you're willing to tackle this on your own going forward, you feel confident, you feel comfortable with the technology and the numbers and what fits your operation. So again, if you're interested, please reach out to us. And I'd love to talk to anybody. We're taking growers right now. We're really focusing on permanent crops. So in summary, whole orchard recycling is an opportunity for growers to move towards that zero waste production that we talked about. And then obviously that's going to increase our organic matter to our soils when implemented. And then soil organic matter helps increase our water holding capacity, the water infiltration into our soil, nutrient retention, and then our soil buffering capacity. One of the things, again, consider that carbon nitrogen ratio and that fertilization requirement of that young orchard that you're going to be planting afterwards. And then please install your irrigation system with water availability to young trees in mind, because again, if you're using fertigation, that impacts it as well. So that's always needs to be a focus of that new planting, because again, it's a 25-year investment. We want to start it off the best we can. I'll leave a contact slide here. Most people probably know a good way to get a hold of me. I'm on LinkedIn, I'm on Instagram, I'm on a number of different things, but phone, email, I put my licensing numbers up here. And again, I appreciate the time today.
Cory, fantastic job. You really did help a lot of people today. I know that anybody who's watched this has learned a lot and is going to be better at their job as a result of it. So thank you so much. And for those of you watching, I want to say thank you for tuning in today. As you know, all our training sessions are on the Janes USA website. You can view any of them and they're always free to view. We also are on Google, Spotify, and Apple Podcasts. So if you want to listen along while you're working or driving from job to job in your truck, you can do that too. So Cory, again, thanks very much. Cory, I think you're going to be doing a presentation at World Ag next week too. Is that right?
Yes. We got a lot of things going on. These webinars are really taking off, and that's because everybody's I think enjoyed the content and given us good ideas as well. So yeah, we'll be at World Ag next week, and I believe there's 3 presentations from Jane, if I'm not mistaken, Richard.
Yep, there's 3, and you're doing it on.
What am I doing it on again? If you don't know, it's micro irrigation maintenance. That's right.
That's right.
It's like I said, it's my 6th webinar. So
yeah, very popular subject. I know Kevin Stewart's going to be talking about hemp as well.
Yep.
And then Jeff Toole's going to be talking about some additional ag tech. So going to be a great week at World Ag. Hope to see everybody out there. Again, Cory, thank you. And thanks everybody for joining today. We'll see you next week. Thank you.
Thank you guys.